Welcome to this video tutorial on xlminer, the data mining add-in for Excel. In this tutorial, we will learn how to use the partition data tool. Data partitioning. Most data mining projects use large volumes of data. Therefore, before building a model, typically you partition the data using a partition utility. Partitioning data yields two mutually exclusive datasets, a training dataset, a validation dataset, and a test dataset. The training dataset. The training dataset is used to train or build a model. For example, in a linear regression, the training dataset is used to fit the linear regression model, that is, to compute the linear regression coefficients. In a neural network model, the training dataset is used to obtain the network weights. The validation set. Once the model is built on training data, you need to find out the necessary accuracy of the model on unseen data. For this, the model should be used on a dataset that was not used in the training process, a dataset where you know the actual value of the target variable. The discrepancy between the actual variable and the predicted value of the target variable is the error in prediction. Some form of average measures the overall accuracy of the model. The test dataset. The validation dataset is often used to fine-tune models. For example, you might try out neural network models with various architectures and test the accuracy of each of the validation datasets, and then you choose among the best competing. In such a case, when the model is finally chosen, its accuracy with the validation dataset is optimistic estimate of how it would perform with unseen data. This is because the final model has come out with the winner among the competing models based on the fact that its accuracy with the validation dataset is highest. Thus, you need to set aside yet another portion of data which is used neither in the training nor in the validation set. This set is known as test data. The accuracy of the model on the test data gives us a realistic estimate of the performance of the model and on completely unseen data. xlminer allows us to create two kinds of partition. First one, a standard partition, which has subtypes such as automatic, specify percentages, and equal partitions. The second kind of partition is partition with oversampling. Let us look at the standard partition. The standard partition creates three partitions based on the partition ratios provided. Data records are randomly elected and every record has an equal chance of lying in any of the partitions. There are three methods of partitioning with automatic. When this is selected, the wizard by default sets the partitioning ratio as 60% training data and 40% validation data, and no test data set is created. These values cannot be altered. We also have the specify percentages, where unlike automatic, if selected, the user can specify the ratio of the partitions created in terms of percentages. We also have the equal partitions option. By selecting this option sets a partitioning ratio of 33.3% of each training, validation and the test sets. Let us now look at how to use the standard partition tool to create simple random partitions. To create a random partition, click on the xlminer tool available in the add-ins ribbon and then select partition data and then select standard partition. An alert pops out that partitioning at least requires two rows in the input data. So what it means is we have to first provide the data which we need to partition in order to start the partitioning. Once the xlminer add-in has been installed, it comes with a set of predefined datasets which can be used to learn about the partitioning tools. Let us first open one of the sets on which we shall apply the partition. These files are available in the xlminer folder under datasets. As you can see, a number of worksheets are already prepared that contain data. Let us select the wine.xls dataset in order to partition. Once the data source has been selected, click on xlminer and select partition data and then standard partition. A window is opened which contains some options. Here you can see that the worksheet is the sheet from which the data to be partitioned is selected, and this is the workbook in which the worksheet lies. This shows the number of rows in the entire dataset and the columns in the dataset. This part of the window shows us all the headings of the columns, as in the variables available in the entire dataset. We can choose any of these and include them to be in the partition. Let us select all of the variables and then click on this button so that all the variables are available in the partition. In the starting, let us look at automatic partition. On selecting automatic partition, the training set and the validation set maintain a ratio of 60:40. Click on OK to create the partition. The partition being created is also stored in a new worksheet in the same workbook. As you can see, the output has an output navigator through which you can navigate to training dataset or validation dataset by clicking on it. By clicking on training dataset, this part of the output shows the training dataset, whereas on clicking validation dataset, it shows us the validation dataset. Now you can see a brief information about the partitioning we have done. This shows the list of selected variables and the partitioning method. This also shows the number of training rows and the validation rows. If we calculate, we can see they bear a ratio of 60:40. You can see here that a random seed has been chosen. A seed is a number that the system uses in order to pick up the partitioning variable randomly. If you use a random seed, the wizard itself assigns a seed, or you can choose to assign the seed, which is then used to select the validation and training data rows. Using the same seed every time will cause the same rows to be chosen in each of the sets. If you want different rows to be visible in your sets, you have to change the seed. So we can see that a training dataset and a validation dataset has been created using the automatic partition option. Let us now see if how does the partition look if we specify percentages. In order to do this, as previous, we select the standard partition option and then use all variables to be present in the output. Next, we click on specify percentages. Here you see that by default a partition ratio of 50, 30 and 20 is specified. You may either choose to change it according to your requirement. So we can see here that we have set training data, validation data and test data in a ratio of 60:30:10. As previously seen, we have a set seed option which you can use to set a seed. Any digit number can be used as a seed, and then once all the inputs are provided, click on OK and the tool will create a partition worksheet. As previously seen, we have output navigator and a brief description of the methods used. Here the seed can be seen to be as the seed that we have provided. The training row contains 107 columns or rows. The validation row contains 53 rows and the test dataset contains 18 rows. We can select either to view each of these datasets by clicking on the output navigator. This is how we create a partition using the specify percentages option. Let us now look at how to create a partition using the equal option. Click on standard partition and then select equal records in the training, validation and test set. You can see here that the ratio has been set to 33.3% each, and then click on OK after selecting the input variables, and then click on OK to get the partition. You can see how the three rows have equal number of rows except for the test row, which contains the rows after, as the percentage is 33.33, it is rounded off. We can select to view either of any of the data sets. We have just seen how to create a simple random partition using the different options. Let us now look at the other method to create the partition that is partitioned with oversampling. In this method of partitioning is used when the percentage of successes in the output variable is very low in the data set, but we want to train the data with a particular percentage of successes. Oversampling is used in a case where we have a variable of interest which is underrepresented in the data set and we want it to be represented in a particular percentage in our partition. Oversampling is executed as follows. The xlminer partitions the data by taking 50% of the successes value randomly in the training set. It achieves this by randomizing internally. It uses the output variable we have selected for this. The output variable we select should have only two classes. These classes can be numbers or strings. Then checks the percentage success in the training set specified by you and maintains it in the training set by selecting the required records with failures randomly. The remaining 50% of the successes go into the validation set. xlminer selects appropriate number of records with failures randomly so that the success percentage in a validation set matches that of the original data set. If you specify percentage validation data to be taken anyway as test data, the xlminer creates appropriate test set out to the validation set. Let us now look at how to use this tool. Since creating oversampling, the variable to be oversampled needs to contain only two distinct values. Let us select a different set to create a oversampled partition. In the data sets, a set named as catalog multi can be used to create this kind of a set. Let us use this dataset to create an oversampling partition. To create an oversampling partition, we click on partition data and select partition with oversampling. A, and we can see an error has popped up showing the number of rows in the dataset cannot exceed maximum of allowed 600 rows. This is because we are using the demo edition which has a limited data range. Let us click on OK in order to select only the first 600 rows. Here you can see a new window has opened with the worksheet and the workbook names, and it shows that the number of rows in data selected are 600 and the columns are 22. You can see here that we have 22 columns as the input variables that can be selected. We can select all these variables in order to be visible in the partition. Select the variables and then click on this. You can select any of the rows to be input variables, but to select the output variable, it should contain only two distinct values. You can see that whenever I select any of these rows, the button to select it as the output variable is not highlighted. But when I select a target dependent variable, you can see that first we select all and put them in the variables in the partition data area, and then as you see, if I select any of these variables that contains more than one distinct values, an error pops up telling the number of distinct values it contains. So let us select the target dependent variable buyer which contains only two distinct values. We will select these as the input variables and then this as the output variables. We will select this as the input variable and the rest as the output variables. The number of classes shows how many classes or distinct values are present in the output variable, and the specify success class is to select which value of the output variable you want as success. Immediately xlminer shows the percentage in the data found in the percentage of the success in data set. So here the data has 50% of success, that is 50% of customers are male and the rest 50 are female. Then specify the percentage in data set. In this option, you can select what percentage of success will you want the training set to have. xlminer will select those many successes randomly and select the remaining failures randomly. So let us select this as 80%. And then this option is used to specify what percentage of validation will be used as a test set if we want a test set. So let us click on 50% of the validation data set will be used as a test set. After selecting our options, we click on OK. Before that, we have to specify a success class. That is, we want the set to contain 80% of females or males. Let us select on female and then click on OK. What we can see here is that the set contains 88% success rate of female. So we need to specify a higher rate. So let us choose male and then click on OK. Start. We see when selecting a partition to oversampling, a new window is opened and it shows that only 600 rows are selected. Let us select all the variables to be in the validation set in the data set that is partitioned, and then let us select customer gender as the variable to be oversampled, as it is the only variable that contains two discrete values. Here you can see that the number of classes in the customer set are 2, that is the distinct values contained in the variable are 2, and then the percentage success in the data set. If we specify the class, that is the value which we want to be oversampled, we can see that the male class has a success rate of 12.33%. That is 12.33% of the variables of the rows in the entire set contain male as a customer gender. We can then specify the percentage success in training set, that is the percentage we want the male number of customers to be present, and then the percentage validation data set is chosen to specify what percentage of validation will be used as a test set if we want a test set. Let us select it as 40 and then click on OK. We can see that the wizard is partitioning the data. Once the partition is created, what we can see is the number of training rows is 74, validation rows is 180 and test rows is 120. We can see that percentage success of the training variable is 50% in the training data. So we can click on training data to view and then on validation data. In the validation data, the success in the original dataset is 12.33, which is maintained in the validation data, and the remaining is put into the test data. This is how we use the oversampling tool to create a partition with a variable whose success rate is being specified by us. This concludes our video tutorial on partition data. For more presentations, tutorial videos on data mining, please visit dataminingtools.net. Thank you.